Calculus, video 63, antiderivatives. Okay, so an antiderivative, that's the process of undoing the operation of the derivative. So, for example, let's say we have this equation y equals 6x cubed minus 12x squared plus 10. And we want to take the derivative, right? So the derivative of that, y prime, right, this correction here is the derivative. Y prime is equal to 18x squared minus 24x. Okay, that's the derivative of our original equation. The antiderivative would be undoing that. The antiderivative would be going from the 18x squared minus 24x, undoing the operation of the derivative, and winding up at something like 6x cubed minus 12x plus some constant, in this case 10. Okay, that is the antiderivative. It's the undoing of the operation of the derivative. So notation for antiderivative, like how do we know that somebody tells us, do the antiderivative? We get this notation here. This is the notation of do the antiderivative. This is what's called an integral, and we'll have much more about integrals in the coming video. This is the symbol for an integral. And this says take the antiderivative of 18x squared minus 24x. That's the function we have right here. What is the antiderivative of 18x squared minus 24x? And the dx here is we're doing this with respect to x. This should remind you of something when we did our differentials form, right? Recall differentials. When we did differentials, we had dy is equal to f prime of x dx. And so what we're going to say here is, if I would take the antiderivative of each side, I would use the integral symbol here and the integral symbol here. The antiderivative of dy would be y. The antiderivative of f prime of x dx. That is what we're finding here. Right, that is what we're trying to find, and that will give us our function f of x, and we'll see plus some constant c. I'll talk more about that in just a second. Right, so this symbolism here with the dx out here, and the derivative function 18x squared minus 24x reminds us of the differentials that we did before. Okay, so what would be the antiderivative of 18x squared minus 24x? Well, we know that the derivative of, go back up here, 6x cubed was 18x squared. Therefore, the antiderivative of 18x squared must be 6x cubed. So it's 6x cubed. Similarly, the derivative of negative 12x squared here is equal to negative 24x. Therefore, the antiderivative of negative 24x must be negative 12x squared. All right. Then there was nothing else here. There's a zero, if you will, at the end of this, because the derivative of 10, let me erase a little bit, the derivative of 10 was 0. But how do I know when I'm doing the antiderivative that the constant is 10? Because if the constant was something else, let's say it wasn't 10, let's say it was 8, the derivative of 8 is also 0. So if we get the 0 here and we do the antiderivative, we don't really know what constant it came from. Was it a 10? Was it an 8? Was it a 42? Was it pi? We really don't know. All we know is that there was some constant, and that the derivative of that constant became 0. Therefore, the best we can do on the antiderivative is I can't at this point say, oh, that's definitely plus 10. I don't know what constant it was. All I know is that it is plus some constant, c. We call this the constant of integration. And the word there, integration, comes from the integral, right, which is the symbolism, if you will, for taking the antiderivative. So this would be our answer. In problems where we're taking the antiderivative, I give you a function such as 18x squared minus 24x. I say find the antiderivative. You use the symbolism, the integral of 18x squared minus 24x dx. You wind up with an answer of 6x cubed minus 12x plus c. That would be the antiderivative. Now, if you have the antiderivative, you should be able to take its derivative and get back to the 18x squared minus 24x. Which we would, right? The derivative of 6x cubed is 18x squared. The derivative of negative 12x squared is negative 24x. The derivative of our constant is 0. So we have the antiderivative. You can check your answer by taking the derivative and see if you wind up with the original function that we're taking the integral of, or the antiderivative of. All right. In this case, we are basically undoing the power rule, right? The power rule for the derivative is I had this 6x cubed here, and the power rule said I bring the 3 down, multiply it by the 6, and subtract 1 from the exponent, so now it becomes 18x squared. We are, in the antiderivative, undoing the power rule. So how is it that we would go from 18x squared back up to 6x cubed? So first thing is, for antiderivative, how do we undo the power rule? Right, the power rule for derivatives. The power rule for derivatives said this: if I have x to some power n, the derivative of that, I bring the n down, and now it's x to the n minus 1. How do I do this backwards, right? So let's suppose I have 3x to the 4th. How do I do the antiderivative, the integral here, of 3x to the 4th dx? How do I undo the power rule? Well, the power rule said I would take the exponent n, I'd bring it down to the front, and I would subtract 1 from the exponent. Therefore, to undo that, I would need to add 1 to the exponent. And so instead of x to the 4th here, my answer should be x to the 5th. The constant 3 is just going to hang out there, but that's not quite right. Because if I were to take the derivative of 3x to the 5th, the 5 would come down and I'd get 15x to the 4th. But I only have 3x to the 4th here. So it's because when I did the derivative, I had to multiply by that n here. When I'm doing the antiderivative, what I would need to do is divide by that new exponent. So undoing the power rule, I'm adding 1 to my exponent. So instead of 4, it's 5. And then I'm dividing by that new exponent that I got, in this case, 5. Let's see if this makes sense. So I think this is my antiderivative. If I take the derivative of that, I should get back to the 3x to the 4th. Let's see if I do. The derivative of 3/5 x to the 5th. What I'll do is I'll bring the 5 down, so I'll get 3/5 times 5, and I'll subtract 1 from the exponent. I forgot the plus c. Plus c. But the derivative of the constant is just 0. Okay, 3/5 times 5, that is 3x to the 4th. That's exactly what I had right here. Therefore, this must be the antiderivative. Okay, so to do the antiderivative, we take the exponent, we add 1 to it, and then we divide by whatever that new exponent is. So, undoing the power rule. Undoing the power rule. The integral of x to the n dx is equal to, we'll add 1 to the exponent, so now it becomes x to the n plus 1, and then we'll divide by that new exponent, in this case n plus 1. And then don't forget your constant of integration plus c, because there could have been some constant in that function there. That is undoing the power rule. All right, let's try some examples of undoing the power rule. Number 1. Let's say the integral of 4x squared minus 6x plus 3 dx. Okay, so all of these, this is a polynomial. Each term of the polynomial, we can do the antiderivative of individually by undoing the power rule, right? And what you're thinking of is, what function, if I took the derivative of it, would give me 4x squared? And then what function, if I took the derivative of it, would give me negative 6x? What function, if I took the derivative of it, would give me 3? Right? That is the antiderivative. And so the way we do this is, I'm going to look at 4x squared separately from the negative 6x and the plus 3. And I'm going to add 1 to the exponent there. And so I get 4x to the third. And then I'm going to divide by my new exponent of 3. And then it's minus 6. This exponent is 1 for the minus 6x the first. So I'm going to add 1 to that. Now it's 6x squared. And I'm going to divide by my new exponent 2. All right, this is a constant 3, or 3x to the 0, if you will. So plus 3, now x to the first, divided by my new exponent of 1. And then plus some constant c. So it looks like this. 4/3 x cubed minus 3x squared, 6 over 2 is 3, plus 3x plus some constant c. That is the antiderivative. Check it. You don't have to check your work, but if you're not sure, we can check it simply by taking the derivative of 4/3 x cubed minus 3x squared plus 3x plus c, and see if our answer matches this function here, this f prime of x. So what we're saying is this is like f of x, and this is like f prime of x in that differential notation. All right, so let's take the derivative. What is the derivative of 4/3 x cubed? Well, that would be, bring the 3 down, that's 4/3 times 3x squared minus 6x plus 3. Derivative of the constant is 0, and we get 4x squared minus 6x plus 3, which is exactly what we started with up there, 4x squared minus 6x plus 3. So yes, this must in fact be the correct derivative. Sorry, the correct antiderivative. Right, let's try maybe 2 more. Make it a little bit harder this time. Let's say our function f of x is 4 squared of x minus x cubed, and I ask you to find the antiderivative. Find the antiderivative, okay? So let's use our notation. To find the antiderivative, we use the integral symbol of parentheses 4 squared of x. But let's not write it as 4 squared of x. Let's write that as 4x to the 1/2. That's how I would have written it to take the derivative. It's also how I'm going to write it to take the antiderivative. Minus x to the third dx. Don't forget the dx part, that is important. That tells us we're taking this antiderivative with respect to x as opposed to a different variable. All right, so what is that? Well, the 4x to the 1/2, we're going to add 1 to the exponent. So 1/2 plus 1 would be 3/2. and then we're going to divide by our new exponent of 3/2. Minus x to the third becomes x to the plus 1 here is 4th, and divide by our new exponent of 4. And then plus the constant of integration, because that original function could have had some constant there that when we took the derivative of it becomes 0, and we don't know what that constant would have been. Okay, so if I'm simplifying here, I have 4x to the 3/2 over 1 times 2/3, right? Instead of dividing by 3/2, it's the same as multiplying by 2/3, minus 1/4 x to the 4th plus c, otherwise known as 8/3 x to the 3/2 minus 1/4 x to the 4th plus c. All right, 8/3 coming from the 4 times the 2 over the 1 times the 3. Okay, check your answer. See if you have the right thing. If we take the derivative of this antiderivative right here, we did the antiderivative. If we take the derivative of that, we should get back to 4x to the 1/2 minus x to the third. Let's see if we do. What is the derivative of 8/3 x to the 3/2 minus 1/4 x to the 4th plus c? That would be 8/3 times 3/2. X to the 3/2 minus 1 would be 1/2. Minus 1/4 times 4x to the third plus 0. Derivative constant there is 0. That would be 3's cancel. 8 over 2 is 4. 4x to the 1/2 minus 4 and 4 cancel. X to the third. Right, that is what we started with right here. Therefore, this is the correct antiderivative. Okay, one more. How about g of x equals 6 over x squared plus 5 over x? And find the antiderivative. All right, this one's a little tricky. All right, so let's try to use the power rule. The antiderivative, we take the integral of, parentheses, 6 over x squared plus 5 over x. It's important to use your parentheses here. dx, important to have the dx. Okay, if I were to take the derivative, I would want to rewrite this with a negative exponent, like 6x to the negative 2 and 5x to the negative 1. So I also want to rewrite it like this when I'm doing the antiderivative. So I have the integral of 6x to the negative 2 plus 5x to the negative 1 dx. Undoing the power rule, on the 6x to the negative 2, I'm going to add 1 to that exponent. Now, if I have negative 2 and I add 1, now I'm at negative 1. So this is equal to 6 times x to the negative 1, dividing it by my new exponent of negative 1. Okay, I like that. But the next one's going to get really weird. Plus 5 times. If I add 1 to negative 1, what does that become? It should become 0. Divided by 0 plus c. We seem to have a problem here, because the first one's not too bad. I just get negative 6x to the negative 1. But on the second one, that is undefined, right? 5x to the 0, that's 5 times 1 divided by 0. That's undefined. Something is going on here. This is not correct. It's not correct. It turns out that undoing the power rule does not work for an exponent of negative 1. It doesn't work. You cannot undo the power rule this way. So let me go back. Let me adjust my how do I undo the power rule thing. This only works, or it doesn't work, let's say, for n not equal to negative 1. The exponent here can't be negative 1, because if I add 1 to negative 1, I get 0. And if I'm dividing by 0, that becomes undefined. So when we're doing the antiderivative to undo the power rule, can't have n equals -1. So how do I do it? Okay, we'll come back to this problem. Let's just maybe take this piece as a side note. The integral of 5x to the -1 dx. Let me rerun it back to where it started from. This started from 5 over x. This is the integral of 5 over x dx. And so we can't use the power rule here, but let's just think about where this may have came from. What function, if I took the derivative of it, would give me 5 over x? Well, remember, what is the derivative of the natural log of x? That's 1 over x, right? That's 1 over x. The derivative of 5 times the natural log of x, the 5 just hangs out front, then it's times 1 over x, otherwise known as 5 over x. So when we do the antiderivative, and it's just an x in the denominator, not an x squared, not a square root of x, but if it's just x, to where we end up with 5x to the -1, the antiderivative here is 5 natural log, and it's actually natural log of the absolute value of x plus c. And so when we go back to this here, we can't just do the undoing of the power rule. That's not correct. And so we have this. We have the integral of 6 over x squared plus 5 over x dx. We're going to rewrite that as the integral of 6x to the -2 plus, I'm going to leave it as 5 over x because I recognize the antiderivative there more easily as the 5 over x to be the natural log of the absolute value of x. Okay, on the first one we can do power rule. We take the 6, we add 1 to the exponent, and that's -1. We divide by our new exponent. But we can't do power rule on the 5 over x, so we just get 5 plus 5 natural log of x, and then the plus c. With a final answer here of -6 over x, right, the x to -1 down to the bottom there, plus 5 natural log of x plus c. And that is the antiderivative. I've lost my absolute values. There we go. Plus 5 natural log of the absolute value of x plus c. That is my antiderivative.